Hello and welcome to part 2 of the series looking at the HP 82143A Peripheral printer for the HP 41C line of calculators. In part 1 I covered the basics such as powering the printer, plugging it in, and some basic printing features such as printing registers and flag settings for wide print and lowercase, etc. In this video I'll be covering the accumulated printer output here and also the plotting capabilities of the printer. Just thought I'd show you the box of paper here that I picked up. Now just a note on this particular calculator. I mentioned that I found this at a recycle centre shop, this printer here. This calculator I found at the same shop, and normally never really find anything of interest at this particular shop, but for some reason I found these two things not on the same day. But this calculator here was in a big box of remote controls, and funny thing is I never normally look through boxes of remote controls, but I did that day and I found this. So someone must have thought that this was a remote control of some sort, and it went in with the rest of them. So yeah, I grabbed it and brought it home and gave it a once over clean up and test, and it's in perfect working order. The only thing really is just a little nick out of this button here, but yeah, pretty good for a tip find. I think I paid $1 for it. Seriously, that's like 50 US cents or something like that. They just had no idea what it was. So yeah, just neat what you find when you're out and about. And this here I picked up, I think, at the same place. I'm not too sure. I can't quite remember. But anyway, this is the original paper for the 82143A, which we've got here, and also the thermal printer, the 162A that I showed you in the previous episode. That's the IL device printer. So yeah, it's showing here that it's not for the 91, the 92 or the 97. Yeah, I've got a 97S as well, so it's not for that. And yeah, as you know, typical HP, it's got a part number even for the paper, 82175A. And here we have the actual, these are original HP black print thermal paper. And you can see there we've got a part number for the individual rolls as well. So 1184, 1106, that will be, I guess, the part number for the roll itself. But I guess that part number's for the entire box of paper. So anyway, hopefully today I get a little bit more life out of the battery on this here. I've got it plugged into the power, so it's always getting power there. But sometimes with the state of the batteries just can't keep up with the amount of demand on them. So if that gets too bad, I'll hook up my external power supply to the unit and get a reliable power source there. Yeah, the other thing I wanted to show you as well is the little printer quick reference card here. So that goes through some of the functions, just quick reference on the functions. It's a condensed version of the manual, really. Very condensed. Flag settings and whatnot there. Yeah, quite neat. So the printer here has a special set of registers that enable you to control printing. They're collectively known as the print buffer. So you can queue up characters into the print buffer, and when all the desired characters have been placed in the print buffer, you can then instruct the system to print the contents of the buffer. This process is called accumulated printer output, because you can accumulate information in the print buffer before printing it. In this way you can control exactly what's printed and how it's formatted. So rather than just banging out a print per line, you can store characters into the buffer and then format them, and it goes through that in this manual here. So the first command here is ACA, accumulate alpha. So it's accumulating alpha characters into the print buffer. Executing ACA either from the keyboard or in a program causes all characters currently in the alpha register to be copied to the print buffer. The alpha register is unchanged. Each subsequent ACA execution places the contents of the alpha register into the print buffer after whatever is already in the print buffer. So let's just go through the example shown here. Oh yeah, so they've just gone through and they've assigned the LN key here. I'll do that just so that we we've got the same setup as the manual there. Okay, and right, so if we go to alpha here and we'll clear the alpha register there, and they've got A, B, C, D, E, so just input A, B, C, D, E, go out of alpha into numeric mode, and we do an ACA, which is assigned to this key here. That's accumulated that alpha register into the print buffer. And then if we go back to alpha and we do F, G, H, I, J, come out of alpha, and we'll accumulate that as well. And then if we put the printer into manual mode, which we've got it in manual, print the contents of the print buffer by pressing ADV key on the printer. Printer advance. Yeah, so that's, yeah, so you can see there A, B, C, D, E, F, G, H, I, J is printed there. And you can also print the contents by executing a ADV from the calculator here, ADV. But there's nothing in the print buffer because it's been cleared. Okay, so if we do that again, and then add it to the print buffer, come back in here, do that there, come out, add that to the print buffer, and then execute ADV. Yeah, you get the idea. And there's a similar method to accumulating the X register into the print buffer as well. That's ACX. So I'll assign ACX here, ACX, accumulate X register to the log key as per the manual there. So if we type in 1, 2, 3, change sign here, and then if I accumulate that by hitting what we've assigned as ACX there, that's accumulated into the print buffer. And now print the print buffer by ADV, and you can see it's printed the X register there, what we transferred from the X register into the print buffer. Pretty straightforward. So with character by character accumulations, there are 127 standard characters that can be printed. 59 of these are on the alpha mode keyboard and can be accumulated into the print buffer using ACA. Using ACCHR is accumulate character. You can accumulate any of the 127 characters one at a time into the print buffer. There's a printout of all the characters there, 127 of them. Got some, special characters down here, lowercase, uppercase, and special characters down here as well. For example, accumulate this character here into the print buffer and print it specify number 15 for that character, and execute accumulate character. We put 15 into the X register, and then we execute accumulate character, HR, and we've now accumulated that into the print buffer. And if I execute an ADV here, ADV, that prints the special character there. So printing the contents of the print buffer. Once you have the desired characters accumulated into the print buffer, you can then instruct the printer to print the contents of the buffer. The buffer is printed left to right. The first character you place on the buffer is printed on the left, and the last character you place is on the right. There are two ways to print contents of the buffer. Two functions that cause print buffer to be printed: prbuff, print buffer, and advance. prbuff prints the contents of the print buffer left justified, and advance on the other hand prints the contents right justified. Once any information in the print buffer is printed, that information is no longer in the print buffer. Okay. The other functions that will cause the contents of the print buffer to be printed are, in general, any function that normally causes printing. print X register, print A register, view, A view, etc. So let's assign, we're going to assign PR buff here into on the TAN key here. Okay, now accumulate characters using ACA, ACX and ACCHR to print this output. So we've got a formatted output here. So we've got plus 25.4 millimeters per inch with an exclamation. So we're putting in 125 here, and then we execute alpha. That's not a plus, it's a little right pointing arrow just before the 25 there. So that is character 125. So we're executing a CCHR here. So we're accumulating that character, and then we'll go to fix one there. We put in 25.4, and then accumulate X, that's that key there. So we've accumulated this number here and from the X register into the print buffer there, and then we go into alpha, we go space mm for millimeters, then shift I think there's actually a typo in the manual here. It doesn't show the slash, so I put in space there, and then shift I gives you a greater than symbol, so there's no actual divide. You do shift divide key to get this / here, and then you do IN alpha, accumulate the alpha register, which is assigned to the LN key there. 33, this will be the little exclamation, and we'll execute alpha ACCHR, accumulate that character, and then we print the buffer, which is the TAN. I've assigned to the TAN key here, the print buff. So go print buff. So you'll notice there, if I hold it, it nulls it, so it doesn't execute the command. And if I just tap it, it will execute the command there, and there we go. We've got formatted text here. So the little right pointing arrow there, 25.4 millimeters per inch. The contents of the print buffer are printed left justified, and the printer is now empty. To see how ADV prints the print buffer, repeat the above keystrokes and press the advance. We won't bother doing that, but you can see it's right justified there. Accumulated formatted and unformatted numbers. Skipping characters in the print buffer. One additional function, skip character, enables you to skip a number of character positions in the printed line. The number of characters to skip is specified by a number in the X register. This function allows you to easily control the format of information you accumulate and then print. Cosine. So I'm assigning the skip character to the cosine button here. Now accumulate the following into the printer. So let's just, just a demonstration here. We've got time with a colon, and then alpha, and then accumulate ACA, which is that one there, accumulate alpha. Accumulate 12 spaces into the print buffer. So if we want to accumulate 12 spaces, and then we put 12 into the X register, and then this key here, cosine, is skip character. The print buffer now contains the string time followed by 12 spaces. To complete the line, accumulate the string 435 into the print buffer. So we're just going to put in a time here, 4:3 5 AM, accumulate, so come out of alpha, and then accumulate alpha. Print the buffer using print buff assigned at the TAN key, and you can see there that we've got time there with the 12 spaces that we skipped over to insert 12 blank characters basically before we accumulated the remaining part there, the actual time, into the print buffer. So you can accumulate lowercase and double wide settings. I went through that, you know, double wide and lowercase in the previous video there. So you can see the result of this here. It's basically showing you how to accumulate my name is into the print buffer from the alpha register, set the flag 12 for a wide, and put R in for the start of the person's name, and accumulate that in from the alpha register, and then set flag 13, which is lowercase, and the rest of the person's name, which is Ray, so AY, accumulate that and then print the buffer, and you can see the result there. Programming with the accumulated functions. All of the accumulated functions covered in this section can be keyed in as instructions in programs that you write. That's the accumulated printing. Now plotting, just quickly go through here, and we'll go through some of the examples here. Interactive plotting operation called PRPlot, print plot, requires basic knowledge of how the calculator is programmed. Read the manual. So the function we'll plot is y equals sine of x here. I'll just work through the example here. So there's a little bit on programming here. So the first of all, we're going to clear the register 3. That's obviously an important register here. So 0, and we'll store that in register 3. 0, 3. We'll go into program mode there, and we'll just do a go to point, and there we go. So yeah, go to point basically just packs all the programs. It gets you to the point where you can start entering a new program. You're not actually part way through any programs. I won't go through that in this video. That's a little bit outside the scope of this video, but I might do a little bit on programming at some stage. So we go, we'll give the program a label, and we're going to call it wiggle, W-I-G-G. Okay, label wiggle. Sign. This computes the sign of the number in the X register. The result is placed back into the X register. That's it. Program done. Go to point to pack the program there. Come out of program mode. Now execute PRPlot. Since the function you are plotting is sine x, it would be useful to plot the values of x from 0 to 360, and the resultant values will be between -1 and 1. These values should be specified as y min equals -1.1 and y max equals 1.1 to provide room to adequately plot the values close to -1 and 1. For this example, the value of x should be increments of 10. So x will be 0, 10, 20, right up to 360. And y will be sine 0, sine 10, sine 20, sine right up to sine 360. The x-axis should be set to 0. PRPlot uses the registers R0 through R11 to construct the plot. Be sure the function you are plotting does not use these registers. Okay, so execute alpha PRPlot. Hello. What's it doing? PRPlot. Yeah, I'm getting this weird memory lost. I'm not sure what's going on there. I've had a bit of trouble with that. Just off camera there. Not quite sure about that. I'll try another calculator here. Doesn't seem to like it. I'm not sure why. Back to the 41CX here. Right. Label. Sign. Packet. Come out of program. Execute alpha. Okay, let's try this time here. See what we get. PRPlot. PRPLOT. Okay, name. So it's asking for the name of the program we want to plot, and it's wiggle, GGLE, and then we run that, and it's asking for the Y minimum, so 1.1, change sign, negative, run, max 1.1, run, x-axis 0, run that, x min is 0, and x max will be 360, and the increment will be 10. And here we go. Plot of wiggle. Hopefully the battery holds out here. Calculating. Nearly there. Battery is really struggling. That's it. I've just toned down the exposure a little bit there just to make it a little bit easier to read on the white paper there. But there's the full plot of the sine function there. So you get the gist of it there. It's just explaining in detail here what the program's actually doing there. Pause and have a read of that if you want to. I won't go through that in huge detail. More on the PR plot program here. Yeah, programmable plotting here using PR plot P, and then you can specify all of your parameters in the actual program through the registers 0 through 11 there. Single line plotting, reg plot, register plot, prints a vertical and one plot value. There's an example of register plot there. Register 0 is the Y minimum, register 1 is a Y maximum, and register 3 is the plotting character. Y min, Y max, and the character 140, that's that little X there. And the number being plotted is 3. You can also do stack plot, so where you fill the stack with your parameters there. Similar sort of thing. Instead of using the registers here, we're using the stack here. And then you can plot with special characters here as well. And that's it for plotting. So I'll leave it there at this stage. I'll go through the graphics in the next video there. Keep an eye out for that one, and I hope you found that interesting. I find it quite neat to mess around with these old calculators and peripherals and things like that. So if you do like to see that yourself, give the video a thumbs up, leave a comment down below. Thanks again for watching, and we'll see you in the next video.